In an earthquake, the most concrete, that is, the strongest buildings collapse first, while earthquake-proof buildings weaken but do not collapse. You may find this strange to hear, but this is the truth of buildings. And after what you are about to understand, you will never look at buildings the same way again. I am not saying this, but great engineers also say this. This story begins when, December 26, 2004, at 7:58 a.m.,
under the Indian Ocean, the Earth shook with a magnitude of 9.1. More than 230,000 people, 14 countries, a tsunami that became one of the most silent killers in history. But that same year, there was an earthquake in Japan too. Buildings were shaking. People were running. The camera was shaking. But some tall buildings in the middle of Tokyo tilted as if they were alive. It wasn't luck. It was science. And there's a dark history behind this science that most people don't tell on YouTube. The 6.4 magnitude earthquake wasn't very big, but what fell shook the entire world. Schools, hospitals, heavy concrete buildings. There were children inside. There were teachers too. One thing became clear, that day being strong doesn't mean being safe. Concrete is strong, but in an earthquake, it's the first thing to break. Engineers were making a mistake. They were making buildings stiff, and the ground doesn't take the stiffness. An earthquake is not an explosion. It's a battle from one side to the other. The ground goes left, then right. Is that the building's natural reaction? After that, the top is left behind, and that's where the building starts to fall. But some buildings have learned not to fight the ground, but to move with it. And that's where the story gets dangerous. Japanese engineers tried a strange idea. What if you don't connect the building to the ground at all? They installed large rubber pads, also put layers of steel and rubber building on top. Ground below, Kobe earthquake, 6,400 deaths. Everything was destroyed. But the buildings that had this system stood. At that time, no one had any idea that this technology would one day make the difference between life and death. One of the tallest buildings in the world. On the top floor, a huge steel ball weighing 660 tons was hanging earthquakes. The building went left. The ball went right. The building went right. The ball went left. It's called tuned mass damper. This is the building's counterattack. This ball is not just for earthquakes, it accelerated the storm. It was for everything. The building doesn't feel like it's alone. Old-fashioned buildings die because of concrete. New buildings survive because of steel. Steel bends. It doesn't break. Tall buildings bend, then straighten back up. This is not a miracle. This is planning. But here's a bitter truth. Earthquake-proof does not mean earthquake-immune. If the design is wrong, if there is corruption, if cheap materials are used, even the best technology fails. In Turkey, in February 2023, the same earthquake of the same magnitude occurred. The same technology was in place. Some buildings survived. Some collapsed like pancakes. The only difference was the right action. The story that is popular on the internet is half true. Now buildings don't just stand, they sense sensors and AI systems before the earthquake starts. The building changes its balance. This is not science fiction. These are projects for 2024. And the next step that is not being told to the public yet. Earthquake-proof buildings are not special because they don't fall. They are special because they correct an old human mistake. Stop fighting the ground. Learn to walk with it. The next time you stand under a tall building and the ground shakes even slightly, remember, either the building is stubborn or sensible, and your life depends on that difference.